Yeah, good evening, everyone. Camps on, everyone. Let's start off. This was the last class ka homework problem. Hope everyone has given it a try. Anyone got an answer? Anish got something. Yeah, that looks right, Anish. Just give me a minute. Yeah, Siddharth, you also got it. Let's see. Let's see how to do this. Then we'll go ahead. So this was the question that we did last time. So we said there was a block. Uh, there are two ways you kept it at rest. One, you kept the strings connected to the four corners. The second thing, you connected the four strings at the midpoint. So something like this picture. You can see how the helicopter is carrying that big block, like, with the four strings on the four corners. And the question was this: the four strings have same length L, and the side of the cube is also L. And the question was find the tension in the strings. Correct, sure. Great. So that's the thing. So let's see how to do this thing. So this was based on equilibrium problems that we have started last time. Others, to keep your cams on. So from here, when you're connecting this string here, it's all geometry again. So when you drop the perpendicular from O, it falls at the center of the cube. This is length L. What will be this length L here? This will be half diagonal, which is L by root 2. Agreed with that? So this angle will be 45. That means the strings are making 45 degrees when you join them to the corner. And this is happening because the side of the cube and the length of the string both are same. And then when you take the components for the strings, so if this string ka tension was capital T, the components will be T1 sine 45, that's your vertical component. T1 cos 45, that's pointing towards the center. T1 sine 45, there's a T1 cos 45 towards the center. You can resolve this into components like along the vertical and the horizontal. And this whole thing is balancing your weight. There you can clearly see the four vertical components are balancing the weight of this whole block. So that would be 4 times T1 sine 45 is equal to mg. So this was the last class homework problem, right? So, and then we got T1 from here is mg by 2 root 2. All clear with this picture? Any doubts on how we got this thing? So the main idea here is to get the angles. Once you got the angles, it is just a matter of resolving horizontally and vertically. And what happened to all this T1 cos 45s? All this T1 cos 45s, you can clearly see they're equal and opposite, so they will cancel out. So the horizontal components won't matter. Is that clear, everyone? Clear, no, Ananya? Got this thing. Then the second part of the thing, you connected the strings in the midpoints of the sides. So this is a right angle triangle. This is length L, and this is L by 2. This is half of the side. So this angle you can clearly see 60 degrees. Cos theta is half. And there, so the picture can be little, like little scary and all, but if you actually carefully see the geometry and try to figure out the angles, that is one thing that we saw in the last class also. Like, most of the problems, more than the picture and everything, it is always about getting the angles. And now if you resolve the components, this thing we take it as T2. So the vertical component will be T2 sine 60. The horizontal component is T2 cos 60. The same way, you will get four vertical components and mg. So we get 4 times T2 sine 60 is equal to mg. This would be root 3 by 2. We get mg by 2 root 3. And the question was asking the ratio. So if you divide T1 by T2, you actually get root over 3 by 2. How did we get 60 degrees? Adjacent side by hypotenuse. Adjacent side is L by 2, hypotenuse is L, so cos theta is half, right? So if you look at this thing, right? So this thing is telling, if you connect the blocks like this, the four corners, that thing actually has more tension. Obviously, you can clearly see there's a 3 in the denominator and 2 here compared to this. But if you see in real life, no one connects the blocks like this. People connect on the corners only. So even though the tension is less, even though the chances of string breaking is less, right? So the thing, right, there is something called equilibrium. We will see later on. If you connect the blocks in the midpoint here, all you need is a small wind and the whole box will start rotating and the whole, the strings will become, what you call, clumped up together. It's called an unstable equilibrium. So there is something like that. So that is the reason people don't use this, even though this thing actually has a, the strings are less stressed out. We'll have to equally for both cases. No, see, Anish, here we are using equal forces all because they're looking identical, isn't it? What if you connect something like this? If tomorrow someone comes and tells you there is one string here and one string here and one string here, now what? Now you can't say all are equal. You're getting it? Now, then it becomes a little difficult to solve. Like we can get the components and stuff, but yeah, in the previous pictures, they were all symmetrical. So we can safely assume they're same. Applied force is still the same. The net force you're saying? Yeah, the total force will be same because that's still mg only, right? They're all balancing the weight. When you say the force, you're talking about the tension in the string. All clear with this question, everyone? Right? Not too tough, not really out of the boundary, right? But it is more to do with the visualizing the angles and stuff. So that's what we did last time, the equilibrium problem. Clear. Great. So let's go ahead. Dhruv, Manav, do keep your cams on. Let's go ahead with one more question. Again, like I keep saying every time, after the class gets over, it is important you revise the whole thing, what we did. Because if you don't do that, next class will feel like, you'll be out of sync. And how do you revise? Take a rough paper and solve every question that we did again. Let's see one more. So we are basically doing resolution of vectors. We are resolving components and stuff. Quite an important thing, actually. In the whole of vectors, if you ask me, this is one important thing. So we have a particle here, which is going on a circle. This is your x-axis. This is your y-axis. So this particle is going on a circle with speed u. T is 0. R is your radius. So meaning after some time, the particle is going to come here. And so on. So this thing is continuously going in a circle. R is the radius of the circle. There are no numbers, so your answers will come in terms of u and r. A particle moves in a circle with constant speed u. Find the velocity vector at time t. Meaning I want you to find I cap and j cap of this velocity. I'll give a little more context. Listen, in case you didn't understand what I'm asking. When the particle is going in a circle, initially, when you're here, you're going which way? You're going up, right? So what will be the velocity vector? Speed is u, and you're going up, so that is j cap, isn't it? After some time, when you come to the topmost point, you're going to the left, so this is u minus I cap. When you're here, it is u minus j cap. When you're here, it is u I cap. You can see what is happening. So every instant, the velocity vector ka direction is changing. It's not constant. Depending on the time, you have different values at different times. So the question is, I want you to give me the velocity vector at time t. Your answer should come in terms of u, r, and t. Yeah, this is like the Dan question which we did before. It's actually the same question. I just asked the vector there. There I asked you position vector. Here I'm asking velocity vector. Find the change in velocity vector. Change in velocity vector delta v bar. So delta means change. So that's how we write this. So this is the change ka symbol delta. So what I'm asking here is final velocity minus initial velocity. So find the vector in the A part and take the initial vector and subtract them. This is called change in velocity vector. Basically, you have to subtract the two vectors. The C part, find mod delta v bar. So the whatever change in velocity you got, uska magnitude chahiye. And this C part is important. You have to remember this result. Exams like me, CET, bits and all, they ask this question directly. If you know the result, saves you time, or else you have to derive. Let's get the first part. All are connected. If you got the first part, you get the second. If you get the second, you get the third. Give it a try. Take a minute or so. Think about it. Then I'll show you anyways. Anyone didn't understand the question? The picture is not clear. Something is not convincing. Please ask. You can always unmute, ask, and get your doubts cleared. Ask. You got an answer? Then I think do type in the chat box to the co-host so that others also can give it a try. And don't worry about writing the notes in the question. You'll get the PDF. So focus on solving, understanding. That's where you should spend all your time. How do I find the velocity vector? So at some time, this thing is pointing this way. So I want this vector ka I cap and j cap. So that's what I'm asking you in case you're wondering what is it. So that u bar is a tangent. So the tangent ka horizontal and the vertical component. Let's say the angle is theta. Now theta also I don't know. You have to find theta also. Cos t I cap, sin t j cap, near Anish. That's not the answer. I know it can be a little confusing, but try another 30-40 seconds and I'll show you. Nee, Ananya. That's not the answer. Okay, let's see. Listen, I'm sure you guys will get this, but I think it looks a little weird, like the alphabets and all, nothing much. So let's say this is angle theta. How much is theta? Anyone remembers how much is theta? How do we get theta? Look at this. So in this circle, after time t, how much will the particle travel? In time t, you will travel a distance of u into t. So this arc length is speed into time. And this is a circular arc and theta. So what is theta? Arc length by radius, so which is ut by r. That is how you get theta in terms of time. Clear? Remember that? Arc length by radius, so that is how you get theta. Great. So once I got theta, again, little geometry now. Draw a horizontal line. If this is theta, alternate angles. If that is theta, this is 90 minus theta. This is theta. So indirectly, what you got is a vector u, and this angle is theta, isn't it? I am asking you, what are these components? So what are these components? This side is touching theta, so that is your adjacent side. U cos theta is upward. The other side is automatically u sin theta. Now be careful how you're pointing. So what is the vector? So this is the vector v bar. This is your vector final. U sin theta backward. So u sin theta, you're pointing to the left. Left is minus I cap. U cos theta is pointing up in the y-axis. That means it is j cap. That's your answer. And what is theta? You have to substitute that. So minus u. Theta will be ut by r. I cap u cos ut by r j cap. So when they ask you velocity vector in terms of time t, this is what they're expecting from you. Yeah. All clear with this? So we need to get in terms of theta, and then you have to substitute the theta back in that. So since it is pointing left, it is there. Now, some people will get confused, sir. How do you know it is an acute angle? Why can't it be here? Why can't it be here? True, it can be anywhere. But in max, right, what we do, we always choose the easiest version. We'll always keep it acute angle. Remember this, not only now. Anytime in physics, we always keep it acute angle. The time will take care of it. For example, see, if you give a large enough time, ut by r, won't this angle automatically become obtuse here? If I give you big enough time, that will become automatically obtuse here. So if the angle becomes obtuse here, look at here, sine of an obtuse angle is still positive. Cos of an obtuse angle will become negative. The signs will take care of themselves. That is the best thing about variables, right? You need not worry where it is. You always choose acute angle. The signs will take care of themselves. And this is not the first time we have done this. Do you guys remember this question? The pen game wala question. There is a rod on a table and it is hit and it is rotating. And what did we do? We said let the angle be theta. We took acute angle, right? And remember this question, the fan thing. This question, yaad hai? Isme bhi we took acute angle. Even though we know the A is actually going something like this, the angle could be anything. So keep this in mind. We always choose acute angles. It makes your life easy, nothing much. And because Max really doesn't care, Max will take care of it. Are you clear with this? The final vector. All sure with this? This is important. Later on in circular motion chapter, right, we are going to do something called differentiation and we'll get acceleration from here. So this is the building blocks. What is the second question? Find the change in velocity vector v final minus v initial. So great. So what is v initial vector? So v initial, it is u pointing upward, the u j cap. That was your initial vector. Initially, you're pointing up. Initial meaning when time is 0. Keep that in mind. Whenever someone asks you, find the initial velocity, find the initial position, initial implies when time is 0. When you start. So you want change in velocity vector, which is v final minus v initial. I'll just put vf minus vi. What is v final? Just now we derived it. I'll keep in terms of theta. You can substitute anyway. Minus u sine theta I cap plus u cos theta j cap. This is your v final minus u j cap. So yeah, this was easy. Bring all I caps together and bring all j caps together. I hope you guys by now realize it, right? You can't add I plus j or anything like that. It's like adding an apple to an orange. Doesn't make sense. This is your delta v bar. Done. Great. The third part. Like I said, this is an important result. You should mug up. Remember this. I want the magnitude. Mod of delta v bar. Now this is more of a max at this point. How do you get the magnitude of a vector? We take the coefficient of I cap, that is this guy, coefficient of j cap, this guy, square them and add them. Hope you guys remember that. Magnitude of a vector. You take the coefficients of I, j, k, square them and add them up. That would be root over u sine theta ka square u cos theta minus u ka whole square. Expand this, you will get u square sine square theta cos square theta minus 2u cos theta plus u square is out, so that is 1 ka root. Sine square theta cos square theta is 1. When you will come out here, then you'll end up with 2. I took out u overall common. Okay, this will be 2 minus 2 cos theta. This would be u into root over 2 into 1 minus cos theta. What is this? You can simplify this further. Now, in case you forgot, this is the first thing we did in the first class. This one, remember, double star. I told you this will come. You will need this. So I'll put it here. You can refer page 15. Basic math, same notes anyway. This was the formula we derived. 1 minus cos 2 theta is 2 cos square 2 sine square theta. This was the formula we wrote. In case you don't remember, now you know. You have to remember this. Max Smith, they will teach you. Max Smith, they started trigonometry for you guys. I think if they have not started when they start, this is like a joke. Okay, they have much more deadly and dangerous formulas. So for us, this is like a small puppy walking on a road. So when they actually teach you max cut trigonometry, it is like a Godzilla walking around. So yeah. So for now, it will look scary and all. This is the relation there. Now we don't want two theta. Look at the formula here. What we have is only single theta. So what we will simply do, replace wherever there is theta, replace with theta by 2. Replace theta with theta by 2. You can do that because the theta is simply a variable. Max doesn't care. So this will become 1 minus cos 2 theta becomes 2 theta by 2. And this becomes 2 sine square theta by 2. Then you end up with 1 minus cos theta is equal to 2 sine square theta by 2. You're done. Then take this guy and substitute here. This will be u into root over 2 into 1 minus cos theta is 2 sine square theta by 2. I'll do one thing, I'll write it here. It's a neat formula to remember, 2u sine theta by 2. These are the kind of questions they'll ask you in CET. Straightforward, direct results. Now think about it. You don't remember this. It's not like you can't do this. You can do this, but yeah, you will spend at least a minute in solving this. So that would waste our time. You could use that time for something more tougher. So if they ask you find the magnitude of change in speed, this is the what to do. So example question would be like this. There is a particle going in a circle. They'll say something of this sort. Let's say the particle is going with 10 meters per second. It has reached somewhere here, 10 meters per second. And let's say this angle is 120 degrees. Then from the formula, mod delta V will be 2 u is 10 sine theta by 2, that's sine 120 by 2, which is sine 16, which is root 3 by 2, just 10 root 3. That's how the question should be. They will say find the change magnitude of change in velocity when the particle is rotated by 120 degrees, when the particle is rotated by something, whatever. I agree with this. Any doubts on the derivation, please ask me. Any step you're not convinced, not clear, why did I do this? What is that? Why did it come? Anything that you're not convinced, not clear, not happy? Yeah, if you're clear, then great, but you should definitely try this again on your own. Getting it? Because I did the whole thing. You did nothing. You just watched it like a movie. It's like thinking, I'll see someone, who is swimming and think, now I know how to swim. Right? So maybe tomorrow, take a rough paper and just put on the whole thing again. All clear with this? Going ahead? Clear, no? Ananya, Tanmay, Meet? Clear?
Yes.
Yeah. Siddharth, Rohit? Clear? Great. Let's see one more and then we will go ahead with something else. That thing is important, what we derived, whole thing, and we'll again encounter those kind of stuff in circular motion. A particle moves with 5 meters per second. Along the line y is equal to root 3x plus 2. This is another way of framing a question. Find the velocity vector. So when you hear this word, right, find velocity vector, find force vector, what they're asking is you want the magnitude and you want the direction, the I cap, j cap. That's what they're asking. So whenever you hear the word find something, some vector, they're expecting you to resolve into I cap, j cap and figure it out. Let's see how will you do this. So this particle is going on a line y is equal to root 3x plus 2. Find the velocity vector. Let's see. How do I cap? Okay, so again, let's see the picture there. It looks scary. Huh? Why is root 3x plus 2 line and all? How are you relating a line to a vector? But everyone knows this much, right? Line equation y is equal to root 3x plus 2. This thing looks like y is equal to mx plus c, where m is the slope. Everyone knows that, right? So here the slope is root 3. And what is slope? Tan theta. And what is theta? Theta is the angle made with the horizontal. That means your line, whatever is here, is making an angle. So and theta is 60 degrees. Now, this line is not passing through the origin. It doesn't matter. We don't care also actually. So all we need is the angle, because a vector can be moved parallel to itself and nothing changes. So the thing that we know, this particle is going along this line, and what is the speed? It's going with 5. So you're done. So resolve into components. So the horizontal component will be 5 cos 60. The vertical component will be 5 sin 60. That's it. That's what is being asked. So what's the velocity vector v bar? 5 cos 60 I cap, 5 sin 60 j cap. But wait, there is one more thing. You simply said you're moving along the line. You didn't tell me which way, right? It could be going up or it could be going down also. So there are two possibilities. This thing could be going down also. So if two vectors are opposite, we'll just put a anti-parallel, right? So it will be a plus and a minus. So there are two possible answers for this. So this will be plus minus 5 by 2 I cap. That's 5 root 3 by 2 j cap. That's it. Just have to be careful. There are two possible answers for this because you can go up or down. Yeah, Anish got it. Karthik got it. Dhruv got it. Rohit got it. Trisha got it. Yeah, most of you got it. Great. Yeah, but like I said, there are two routes, so just be careful with that part. All clear with this? Great. So that is a thing about resolution of vectors and component stuff. So when you say components of vectors, right, this is what they expect from you, right? The questions will be of this sort. No one will just ask you what is I cap, j cap, and all. All clear with this? Going ahead. Next thing, triangle law of vectors. So yeah, if you have done resolution, all this thing will look now normal, easy. So what this thing says, if two vectors are joined head to tail, the resultant vector is from remaining tail to the remaining head. Yeah, I'll show you the picture. Don't worry, it looks just weird, but so what it simply tells you is, imagine, just think of displacement. If you're walking from here to here, let's call this thing a bar, and if you walk from here to here, let's call this thing b bar. Isn't it as good as walking from here to here? It's like your displacement, isn't it? So you're walking from the remaining tail to the remaining head. So that's your resultant. So whenever you get confused, what is this resultant and triangle law? It's nothing. It is simply saying it is as good as walking from here to there. So this is called a resultant vector. We'll call it R bar. So it's basically your displacement. But be careful, you have to join them head to tail. Now, the same way, the extension of this, suppose if you have three vectors, joining head to tail. If you take three vectors and you join them head to tail, forming the sides of a triangle, then the resultant vector is a zero vector. And now again, if you think in terms of displacement, it makes sense. Means if you start at some point, then you go like this, and then again you come back like this. So what is the displacement? Zero, right? If you start there and you go round, round, round and come back to the same point, so yeah, you did nothing basically. So it's a null vector. So we can simply say a bar plus b bar plus c bar is equal to 0 bar. Easy. So nothing. Triangle law simply tells you if you just go randomly and walk around, it is as good as going from the starting to the final point directly. It's a displacement thing. All clear with this? Next thing. Angle between two vectors. So how do you define angle between two vectors? Now here you have to be careful. The convention, right, is this way. When two vectors are joined tail to tail, so this is important. You cannot connect a head and tail when two vectors are connected tail to tail or head to head. You can't connect a head and a tail. The smaller angle between them is the angle between the vectors. I'll show you how it looks. So if this is your A bar and if this is your B bar, so there you're joining both them tail to tail. So this is theta. Example. If someone gives you like this, they will say, okay, this is A bar. This is B bar. And if they say this angle is 120, this is not the angle between the vectors. So how do you do this? Remember, you can always move the vectors parallel to themselves. So keep the B bar as it is and just push your A bar a little forward. So if you push the A bar forward, you'll get the tail to tail. And now this angle previously was 120. Now this angle is 60 degrees. This is your angle between vectors. Is that making sense? Let me give you one more example. Let's say if I have three vectors like this, let's say this is A bar, B bar, and C bar. And let's say if this is 60, 30, and 90. Can you tell me what is the angle between the vectors? What is the angle between A and B? What is the angle between B and C? What is the angle between A and C? Remember, they have to be connected tail to tail. These all are head and tails are connected. So you can't say 30, 60, 90. People do goof up in a flow, right? Meaning it looks silly, but when you're under so much pressure in the exam, people do such mistakes. We call them silly mistakes. What are the angles? Remember, you just have to push them in such a way you get tail to tail. Right on, Andy. Think. I'll go another 15, 20 seconds. Like I said, all you have to do is think. Nahi re Karthik, how will you get that? Okay, see, I will keep B as it is. I'll push A forward. And I'll, this was easy. So A and B was 90. And I can, even push C also this way, like this. You're getting it? And you can clearly see here, see, when you extend like this, how much was this angle? This was 120. So this was 120. This was 90. And the total angle must be 360, right? So you can directly say it's 150. Clear with that? So what is the angle between A and B? 90. A and C, 120. B and C, 150. Any doubts on this? Easy. Got this? There. So that is how you define angle between two vectors. All clear? Any doubts on this concept? Great. So let's see a question on this. So I'm giving you magnitude of three vectors. So I'm giving you magnitude of three vectors, A bar, B bar, and C bar. Means I'm telling you what is the length of the vectors. I'm not giving you angles. I'm not giving you, the nothing. You can arrange them however you want. Magnitude of three vectors are given, right? We can arrange them in any direction. That's your choice. So the first one, let me give you them. So mod A bar, mod B bar, mod C bar. Mod means magnitude. Let's say 3, 3, 3. So you have three vectors of 3, 3, 3. 3, 4, 5. 6, 6, 7, 4, 5, 10. 1, 1, 2. So these are five different questions. So the first question, which of the following vectors can form a zero vector? Meaning you arrange them however you want. Is there a possibility they can all cancel out? Which of the following can give a zero resultant? Like I said, I give you a free hand. You can put whatever you want, angles can give a zero resultant. If they can give zero resultant, then what should be the angles between them? If it is not zero, then fine, you need not find the angles. But if resultant is zero, then at what angle should you keep them? Again, you can't keep whatever angles you want. There's a specific set of angles for which they'll be zero. If resultant is zero, find the angles between them. The second part of the question, what is the maximum and the minimum magnitude of the resultant? So these three vectors, if you can put them however you want, what is the maximum and the minimum possible value of the resultant? I hope everyone is clear what I'm asking. Try, take a minute and I'll show you one. So first question, you have three vectors with you. Let's say first one, 3, 3, 3. Arrange them however you want. Is there a possibility they can all cancel out? Yes, then what are the angles? No, then the first part is done. Second part of the question, if these three vectors can be added any way they want, what is the maximum and what is the minimum you can get? Okay, Rohit. Oh, that is right, Dhruv. Try. Get all of them, Aram, no worries. Okay, let's see the first one. Let me show you one. Rohit, you have to tell me the angles. Yes, 0, 0, 1, 0. Angles, Ishi angles. We need to get the angles. That's the major one. Okay, let's see the first one. So 3, 3, 3, right? How can you arrange them? 3, 3, 3. Now, before that, like, what is the condition to get a zero vector? Yeah, some of them, right, you can see and tell. Some of them it is difficult. But remember this one statement we just made it. If three vectors form the sides of a triangle, then the sum is 0. And what is the property of a triangle? The sum of two sides is always greater than the third side. Remember? As long as you satisfy that condition, you can be sure they form a triangle. If three vectors form a triangle, then the resultant is 0. That we got from the triangle of vectors. And to form a triangle, you should satisfy this condition. You can take even difference between two sides is greater than the third side. You take sum of any two sides, must be greater than the third side. Now, from this logic, right, you can clearly see the first one will work, second will work, third will work, fourth is gone. The fifth also looks like it goes off, but there's an exception, can be equal to also. Now, let's see the game. The first one, 3, 3, 3. Yeah, it's obviously an equilateral triangle. And if you say the angles are 60, you're gone. So that's where you have to be careful. A, B, and C. This is 60, this is 60, but this is 60. That's not how you measure the angles. You have to put them tail to tail. So this is A bar, this is B bar, and this is C bar. So you have to put the three vectors at an angle of 120 degrees with each other. Are you clear with this, everyone? So don't say 60, 60, 60. That'll be the first option in the exam. I hope now you're getting it. So the second one answer is not 3753. Right? So what is the maximum possible value? See, you get maximum value when you add all of them in the same direction. So just put all of them in the same direction. So max value is 9. Minimum value is automatically 0 because they can form a triangle. Perfect. What about the second thing? 3, 4, 5. 3, 4, and 5. So this is A, this is B, and this is C. This angle tan theta 4 by 3. So this is 53 degrees. So if you extend the vector here, this would be 127. So A bar, push C bar down and put the B bar here. So you join all of them tail to tail. And you can clearly see the angles. This is 127. Look at this thing here. If you extend this is 37 and this angle will be 143. This is 143 and that's 90. Again, max value, add all of them, 3, 4, 5, that's 12, and minimum value is 0. Meaning these three vectors, no matter how you add them, you cannot get a value more than 12. Is this all clear, everyone, what I'm asking? The angles part? It's not 37, 53, and 90. If you do that, you're gone. And that will be the first or second option. I hope everyone is clear what I'm asking now. How to do the third one? 6, 6, 7. That's not any standard angle. But can it form a triangle? Yeah, 6 plus 6 greater than 7, 6 plus 7 greater than 6. Yeah, that works. It's an isosceles triangle, that much I know. How do you get the angle? You won't get any standard angle. We have to use cosine rule. So A6, B6, C7, right? So if you take this angle to be theta, this angle to be theta, this angle will be 180 minus 2 theta. And I hope you guys remember cosine rule. So what are the angles? If this is A, the opposite angle will be capital A. If that is B, the opposite angle will be B, and that would be C. The cosine rule says cos A is the angle opposite to the side A, is B square plus C square minus A square by 2BC. And where did you do this? Again, basic math. Here, page 17, cosine rule. You should remember this. Mug it up. So whenever they give some weird triangle and they want angles, cosine rule. And the jump the values there. 6 square, 7 square, 6 square, by 2, b is 6, and that's 7. 6 and 6 are gone. 1, 7 is gone. That's 7 by 12. So that's your theta. So you can say theta is cos inverse 7 by 12. But that's not the answer you want. Huh? You have to put them tail to tail. So this is A bar, C bar, and B bar. And then you get the angles 180 minus theta. If you shift right, B and C, that is also 180 minus theta. And this is 2 theta. Yes, that's your answer. You can leave the answer like this. The fourth one, yeah, it can't be, not possible. Can't get a zero vector. But what is the maximum value? Just add them up. Max value will be, what are the vectors? 5, 4, 10. But how do you get the minimum? Now remember this, whenever you want to find the minimum value, right? If you're not getting zero, this is what you do. You take the two weakest guys, keep them in the same direction, and keep the strongest guy in the opposite direction. So whenever you want to find the minimum value, that's what you do. If they're not forming zero, this is the only thing there. So the minimum value is 1. Meaning these vectors will be always between 1 to 19. Do no matter what you do, you can't get more than this. The fifth is an interesting one. You can actually put two vectors, 1 and 1, opposite, and you can get 2 this way. In physics, we call this thing, this is a triangle with zero height. So yeah, it can get a zero vector. And what will be the angles? 1 and 1 are parallel. So this is 0 degrees, and this is 120, 180, and 180. Yeah, this is possible. Max value is 4, and the minimum is 0. Any doubts on this? All clear with the angles? Manav, clear? Ananya, clear? Siddharth, Rohit, Radhika, Tanmay, Karthik, Meet, clear? Great. Next thing. Polygon law of vectors. So this is an extension of triangle law of vectors. So what this thing says, in triangle law, we dealt with 3 vectors, right? Here, if you have multiple vectors, if n vectors are joined head to tail, same story. The resultant is from the remaining tail to the remaining head. It is the same thing, Dhruv, head to head or tail to tail. Told you, na? There's no difference between them. Just don't connect a head and a tail. Right? Because if you have two vectors like this angle and this angle are always equal. So head to head or tail to tail, it is the same thing. Clear? Let's say you have vectors like this. So A, B, C, D, E, F, and G. So if you are adding all the vectors A to B bar, B to C bar, like I said, just a displacement CD bar, DE bar, EF bar, and FG bar. So if you add all this, it is as good as walking directly from A to G, isn't it? That's your polygon law, nothing much. So if you just add n vectors, you take the resultant from the remaining tail to the remaining head. So it's an extension of a triangle law. In triangle law, you dealt with 3 sides. Here you can deal with more. Dhruv, are you there? Okay, your cam's not working, I guess. I can't see you. It's completely dark. So do check out your camera, see what went wrong. Great. Let's see a question. We have an hexagon A, B, C, D, E, and F. So is the center. There are 6 sides. This is a regular hexagon. What is a regular hexagon? All the sides are equal. That is called a regular hexagon. And now if you add the vectors A, B bar, so if you're adding A to B, then you add A to C plus A to D plus A to E plus A to F. It is given, this is n times AO bar. N is an integer. Find n. These are the kind of questions you get in integers in mains. Meaning, again, I'll just tell you the context, what is happening. See, you took a vector here A to B, you took a vector A to C, you have vector A to D, A to E, and A to F. You're saying you're adding these 5 vectors. And this saying these 5 vectors is n times A to O. So when you add all these vectors, you get a vector in the direction of A to O. You can kind of see, right? There's a similarity, a symmetry here. You can see they're all pointing, when you add them all, it looks like they'll go from A to O. So he's asking, it is n times A to O. So what is that n? N is an integer. So it's like a number, 1, 3, 4, something like that. Nay, Dhruv, don't guess. Don't guess. If you guess, you'll get a -1. Don't use your feelings. Solve. This is not a feelings class. This is a physics class. So when you want to guess, right, ask yourself, if this is the final exam, will you have the guts to mark that answer? Right? Without your hand trembling, will you have the guts to mark the answer? I think. Yeah, if you say no, then I think you should not guess. Nay, Anish, that is wrong. So finally, Dhruv, what did you decide? Which answer? Okay, Aishi, right. Siddharth, right. Dhruv, right. Tanmay, right. Try others. Try. I'll give another 40 seconds, maybe 40, 45 seconds. It's a good one. You need to think of it. Nay, Anish. Looks like some of you did this before, maybe. It's a standard question, though. Nay, Ananya. Logically, be socho na. If all are like this, how can they cancel out? Imagine it is you, okay? You're standing here and 5 friends pull like this. You will not move. You will be at rest until unless you're some Salman Khan or something like 5 rowdies are pulling Salman Khan and he's not moving. So listen, there's an interesting way to do. Today is your seniors ka JEE mains ka result, right? So before your class, that only we just had their advanced revision program is going on. The results are out. I think people are just calling me non-stop now. Okay, got so far 2000 rank, 5000. Okay. 7. Nahi, Rohit. Let's see. So What do you want to add? AB bar, AC bar, AD bar, AE bar, AF bar. Great. Now, first thing, you need to understand something. See, in a regular hexagon, this length and this length are equal. You guys remember that? If you see in a regular hexagon, right, in case you forgot, we have told you in physics, equilateral triangle, square, regular hexagon, circle, a parabola. We'll talk about that later on. These are the standard shapes. And an ellipse, they keep coming. So what is a regular hexagon? A regular hexagon is nothing but 6 equilateral triangles. If you join all these opposite sides, you will notice there are 6 equilateral triangles. So if this is A, this is also A. So all the sides are equal. Okay, so great. Now, see, understand one thing. What do you mean by A to B? You want to go from A to B, right? And it is given in the question, you want everything in terms of AO. So let's bring AO everywhere. Can I write like this? If you want to go from A to B, I'll go from A to O bar, plus I'll go from O to B bar. Can I say that? To go through A to B, I will travel from A to O and O to B. Great. What is A to C? I'll go from A to O, then from there I'll go O to C. Great. What is A to D? Now, you can clearly see A to D is nothing but A to O plus O to D. And they both are equal. We'll see that. What is A to E? Go from A to O, then go from O to B. That's it. Basically, you bring AO everywhere. AO plus OF. And now you notice something here, say. If you look at the vector OB bar, OB bar is like this. This is your OB bar. This is OE bar is like this. So both are opposite vectors. So OB vector and OE vector will cancel. Make sense? OB and OE are opposite vectors or anti-parallel vectors. Same argument you can say OC is this way, OF is this way. They are also opposite vectors. So OC and OF is also gone. So when you do this, you're left with AO, 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 and one OD. And you can clearly see here AO bar is equal to OD bar because they both are parallel. Make sense? So this whole thing is 6 times AO bar. Therefore, n is equal to 6. No calculation, nothing. You just use the polygon law principle there. And how do you know how to do this way? Ask yourself. In the options, it is given A to O bar. Somehow you have to convert all these vectors in the form of A to O. Yeah, there are other ways to do this also. You could have written this thing as, AB bar. You can write AC as AB plus BC, AD as AB, BC, CD. You can do that. It works. You'll get the same thing no matter what you do. But this is one way to approach this. Clear with this? Any doubts on this? How did you approach this? Everyone is clear now? AD and OD are parallel. This is AO bar. You can clearly see they're in the same direction, right? A to O and O to D, they're parallel vectors. They're equal. Clear? Great. Take a break. Come back by 9:40. We'll continue from here. Any doubts so far? Anything you're not clear? Go away from the screen for 5 minutes or 10 minutes. Come back by 9:40. We'll continue from here. Anyone confused with anything? Any doubts? Chalo, come back in 10 minutes then. Great. Let's see one more. So let's say we have a point here, A. Let's say we have a point here, B. So from origin to A, this vector is called A bar. From here to here, this vector is called B bar. Now between A and B, so when you join the line AB, there is some point C in the middle, which divides the line in the ratio of m is to n. This is C. Ratios basically. So point C divides the line AB in m is to n ratio, maybe 2 is to 3, 3 is to 4, and so on. So using this information, you need to find the vector OC bar or simply C bar. So your answer should be in terms of m, n, A bar, and B bar. Meaning if I change, for example, let's say if I say m is equal to n, then it will be the midpoint. So by changing m and n ka values, I can move the vector C bar. So point C is moving on the line AB based on m and n ka values. How do we approach this? Everyone knows ratios, right? Suppose if something says, it is divided in 2 is to 3 ratio, how do you divide this? 2 by 2 plus 3. So into the total whatever. So we have a vector A bar, we have a vector B bar, and the line AB, there is a point C somewhere in the middle. And it divides in the ratio of m is to n. And what is C bar in terms of A bar and B bar and m and n? Give it a try. How do we approach this? Any ideas? Think, take a minute. It's completely fine if you don't get an answer, but let's see. Okay, let's see. C bar, A bar minus B bar. Not sure what you wrote, Ananya. Dhruv, A, B, I, J. There is no I in J here. It's like Prisha, M, B, A, B. Yeah, Prisha, you got it. Let's see. We have one answer there. Okay, so it is given that C divides in the ratio of this. We can write this AC by CB in the ratio m is to n. So I can write this as n times AC bar must be equal to m times CB bar. They're parallel vectors. Agreed? Because AC and CB, they are parallel. So what is AC bar? AC bar, you're going from A to C. So that is C bar minus A bar. Remember, final minus initial. What is CB bar? You're going from C to B. So final vector is B bar, initial vector is C bar. So now you can rearrange the terms n c bar, n a bar, m b bar, m c bar. So bring everything here, c bar into n plus m. Remember, n and m are scalars. N a bar plus m b bar. That's your ratio there. I hope Aaron understood how I got that AC bar. In case you were confused, let me show you this thing. Say OA bar plus AC bar, this comes from triangle law, is equal to OC bar. So we can write AC bar is OC bar minus OA bar. But OC bar is same as C bar and OA bar is same as A bar. Similarly, we can go OB bar OC bar plus CB bar is OB bar. This is the triangle law, right? O to C, C to B is as good as O to B. So from here we get CB bar is OB bar minus OC bar. This is B bar minus C bar. So in case someone is confused what is final minus initial, you can also show the same thing with the triangle law. Yeah. Right, Ahna. Right, Annie. I think you all got it. Clear with this? Easy one. So it's like you have to use the ratios there. That is the idea there. If you got that, it would have clicked, or else yeah, it would have been a little weird. Any doubts on this? Clear. Great. Going ahead. Next thing. Parallelogram law of vectors. So these all are like, what we did right in that resolution of vectors. These are not that interesting, but yeah, these are concepts, important ones. So it should do it. Parallelogram law of vectors. So what is this thing? So if you consider two vectors A bar and B bar, with an angle theta between them. Right. So remember, we can always move the vectors parallel to themselves and nothing changes. So we can actually move these vectors, creating a parallelogram. Parallelogram. So it's a quadrilateral with parallel sides. So this is how we do this thing. So this is O, this is A, this is B, and this is C. So this vector is your A bar. This vector is also A bar because both are parallel. This vector is B bar, and this vector is also parallel, B bar. OC is your diagonal. This angle is theta, and this angle is also theta. Now, using little geometry here, we can get the length of the CD there. So you want to find the vector from O to C. So think of like this. So when you go from A bar, so OA bar plus AC bar. So OA bar plus OB bar. Or you can simply say A bar plus B bar. Is OC bar. So the resultant vector. So this angle is also theta. From here, drop a perpendicular. Let this point be D, and we know this side is B because this is also B. And this would be the opposite side, which is b sine theta. And this would be the adjacent side, which is b cos theta. And this length here is a. Now in the triangle OCD, we can clearly see it's a right angle triangle. OC square will be OD square plus CD square. So OC square will be C square, OD will be A plus B cos theta. CD will be B sin theta cos square. Expand them. That will be B square cos square theta plus B square sin square theta. Sin square plus cos square is 1. So you end up with root over A square plus B square plus 2AB cos theta. If you actually see this carefully, right, this is a cosine rule, isn't it? If you see carefully, this is a cosine rule. You can put cos theta one side and shift everything. You get cos theta is A square plus B square minus AC by 2AB. It kind of looks like that. So what is this parallelogram actually useful for? So if you know two sides and if you know one angle, you can get the third side. So it's basically indirectly the cosine rule. So let me put it in a more usable form. The derivation is really not that important because it is there for 11th boards, but yeah, 11th board exams are not there. So anyway, so you're safe. So if you have a triangle, so let's say this is O. So this is A bar. This is your B bar. This is also B bar. This is your C bar. So if C bar is A bar plus B bar, that's the resultant vector. Then the mod C bar or mod A plus B bar is given by root over A square plus B square plus 2AB cos theta. So if I know the two sides A and B, and if I know the angle between them, I can find the resultant. Other than that, I can also do, suppose if this is A bar and this is B bar. So this is what we got. This is your C bar. If you take, this is the angle alpha. If you take this angle as beta, we get tan alpha. Again, from here, from the geometry, we can clearly see tan alpha is the opposite side, which is CD by OD, which is B sine theta plus A plus B cos theta. You can note down these formulas if you know better, you won't remember this or else. Yeah, and you can always try them if you want. Cos theta. Similarly, tan beta, I'll tell you what is alpha and beta exactly. You just need to reverse A and B and you'll get this. So C bar is the resultant vector. So the resultant vector of A bar and B bar is C bar. So when you add the vectors A bar plus B bar, be careful, we are not adding A and B, we are adding two vectors. Alpha is the angle between the resultant C bar and A bar. Beta is the angle between the resultant, that is C bar, and B bar. There, this much you should know. So these are the main formulas to remember. The magnitude and the angles, that's it. But you know, you'll really rarely use this thing. I think in physics, right, whenever we have vectors, we always do vector resolution, I cap, J cap, and we solve problems. This thing is pretty rare. Meaning, even if it can be used, we will rarely use this. But anyways, vector smith is there, so we will do it. All clear with this? Others, do keep your cams on. Anish, Ahna, Dhruv, you have to keep your cams on. Great, a little more on this thing. Listen. So you said the C bar is the diagonal, right? That's what we got there. They can ask some theoretical questions on this. So see, this was A bar, this was B bar. So then the resultant is from the remaining tail to the remaining head. This was C bar. Great. What if you draw it like this? Let's say this is A bar, this is B bar. You draw the other vector, let's call it D bar. Now look at this. C bar is A bar plus B bar. But look at this. B bar plus D bar. So head to tail, then you get your A bar there. So D bar is A bar minus B bar. So A plus B and A minus B are the two diagonals of a parallelogram. Everyone keeps talking about A plus B, but in a parallelogram, we have a second diagonal also. So if they ask you what is the two diagonals in a parallelogram, A plus B and A minus B. AB are the sides and A plus B and A minus B are the diagonals. Great. Clear this? So that's one. Next thing. What is the condition for a parallelogram to become a rhombus? What should be the condition? What should happen to A and B so that a parallelogram becomes a rhombus? What happens in a rhombus? The sides are equal. Dave, are you there? Hello, Dave. Why can't I see you? Dave, are you there? You're not there. Dhruv, your cam, what happened? It's working, not working. You just came and went off. You need to do something about your cam, Dhruv. Next class, I won't allow you. Yeah. Condition for rhombus. So for a rhombus, right, what should happen? The sides must be equal. Mod A is equal to mod B. Or in a rhombus, the diagonals are perpendicular. Actually, both they satisfy each other. If you say diagonals are perpendicular, automatically the sides become equal. If the sides are equal, the diagonals become perpendicular. What is the condition for a rectangle? What is the condition if your parallelogram becomes a rectangle? The sides must be 90, right? So A bar must be perpendicular to B bar. That's it. They need not be equal. So if you have two sides and both are perpendicular, automatically you get a rectangle. What is the condition for a square? So these are all the conditions to convert a parallelogram into other shapes. So for a square, mod A must be equal to mod B. The sides must be equal, the magnitude, and not an or, and A must be also perpendicular to B. Clear this? So if someone asks you what is the condition for a parallelogram to become a square, it has to satisfy both. Clear with this? So parallelogram law of vectors, theoretical things, this is the kind of things they'll expect you to ask. And yeah, the formulas are anyway there. I hope everyone has copied down the formulas. We will need them. All clear? Great. Let's see some problems on this. So primarily, when they use parallelogram law, if they give you the sides and ask you an angle, or they give you one angle and two sides and ask for the third side. So let's see. Mod A bar is equal to 3, mod B bar is equal to 4, and mod C bar is equal to 6. And it is given the resultant vector C bar is equal to A bar plus B bar. Find the angle between A bar and B bar. Get them. There are two questions. You can leave your answer in terms of cos inverse. Yeah, right, Prisha. Right, Anish. Nee, Karthik, check your answers. Near Ananya. Should I show you the first one? I'll show you the first one. So here you're saying C is A plus B bar and you want the angle between them. Great. So what is the formula? C is equal to root over A square plus B square plus 2AB cos theta. And what is the theta? Theta is the angle between A bar and B bar. So that's what you're asking. So the two vectors which you are adding, the angle between them is A bar and B bar. You're done. There's nothing there. Formula substitution. Put 6 here. So that will be 6 root over 3 square, 4 square, 2 into 3 into 4 into cos theta. If you put square on both sides, that will be 36. 36 minus 25, that's 11. That would be 4, 3, 12, 24 cos theta. We get cos theta is equal to 11 by 24. Yeah, you can leave the answer like this. There's nothing more you can do in this. Yeah, you can write theta is equal to cos inverse 11 by 24. That's it. There's nothing, that formula substitution. All clear with that? What about the second one? Same thing. I didn't give you numbers, but I gave the relation between them. Mod A is 2, mod B is equal to 3, mod C. Trisha, you got it, but you got it wrong. Your calculations are right, but you got it wrong. That's weird, right? Think. A and B, there is no difference between the equation. In A, I gave you numbers. In B, I gave you the relation between A, B, C. So it's a ratio, they get cancelled anyway. Let's see how you approach this. Nere Anish, that's wrong. Your calculations are also wrong. Yeah, you can take anything you want through. That works. Let's see. Rohit, what did you even get? Okay, let's see. So mod A is 2 times mod B is 3 times mod C. Great. So C square is A square plus B square plus 2AB cos theta. So just convert everything into one form, right? So let's do one thing. Let's keep everything in terms of A. So what is B? So B is A by 2. So if I take these two, B is A by 2. If I take C, that is A by 3. So I'll convert everything in terms of A. So this guy would be A square by 9, A square, and B is A square by 4 plus 2, A by 2 cos theta. So you can see A square will cancel on both the sides. You'll be left with 1 by 9, 5 by 4 plus cos theta. So then we get cos theta. It shifts that side. That will be 4 minus this thing, minus 41 by 36. Got this? And this is a blunder. And this will be the first option. Anyone figured out why? Cos theta can't be less than -1. This value -41/36 is exceeding -1, is below less than -1, isn't it? So what's wrong with this? You're getting it. So thing is, just look at the values. For the sake of the numbers, let's give some numbers. Let's say A is 1. So for example, if A is 1, then B is half and C is 1/3. Can these three form a triangle? Look at this thing. If you do A and B, if you subtract them 1 minus half, you get half. There is no way you can get 1/3. Meaning, whatever values I gave, these kind of vectors don't exist. Getting it? This is not possible. So this is the max way of saying, boss, whatever you're asking is not going to happen. So if you ask things which won't happen, max will give you garbage values. So this is the max way of saying what you're asking is not possible. So the fourth option will be there, none of this. So such vectors don't exist. You cannot get three vectors like this which will give you an answer. Are you clear? So if you got this right, calculation wise, your calculation is nothing wrong with this. But you need to realize the cos theta value went below -1. So that doesn't make any sense, isn't it? That's it. So that's what makes this little good. All clear with this? Any doubts on this? Yeah. So after getting an answer, it always has to, think for a moment, like, does this even make sense? Great. Let's see one more. Let's say mod A is equal to 2, mod B is equal to 3, mod C is equal to 4. C bar is A bar plus B bar. Find the angle between A bar and C bar. And B bar and C bar. Basically, that's alpha and beta ka things. So again, just a formula substitution. Let's get this. How do we do this? Cos inverse 11/16. Okay, that's alpha. Yeah. How did you get cos? I'm asking you alpha and beta. Na? Let's see. So this is your A bar. This is your B bar. This is your C bar. Remember, this was alpha, and this was beta, and this was theta. You need theta first. So we get C square is A square plus B square plus 2AB cos theta. So we need to get theta from here first. So C is 4 square, 2 square, 3 square, 2 into 2 into 3 into cos theta. That would be 16 minus 4, 12 minus 9, 3. 3 and 3 goes off, so we get cos theta is 1/4. If cos theta is 1/4, now listen to this thing. I want to tell you something. Listen, this is important. This will keep coming. If I give you cos theta, how to get sin theta and tan theta and all that? You can use root over 1 minus cos square theta and all. It's boring. This is a better way. Listen. if I give you cos theta or sin theta, how to do it? Make a right angle triangle. Cos theta adjacent by hypotenuse. So adjacent is 1, hypotenuse is 4. Use right angle triangle, Pythagoras theorem, root 15. So you want sin theta, opposite side root 15 by 4. You want tan theta, root 15 by 1. Clear with this? Not a big thing, but yeah, remember this. So sometimes, you get sin theta and you want tan theta. This is the best way to do. Make a triangle and finish it off. Great. So what is tan alpha? Go back to the formulas. Tan alpha was b sin theta by a plus b cos theta. There you know everything here. Substitute. B is 3. Sin theta is root 15 by 4. You won't get good answers. A is 2 and B is 3 and cos theta is 1 by 4. How much is this? 4 to 8, 11. That would be 3 root 15 by 11. This is not a good answer. 4 to 8 plus 3, 11. Yeah, perfect. You can leave it like that. No need to simplify it further. What's tan beta is sin theta by. All these are brute force problems. You know the formula, substitute and you'll get it. There is nothing to think like what we did last class. Last class, at least, we're using our head in finding angles and geometries and all. This is brute force. This is 2 sin theta is root 15 by 4 by b is 3 plus 2 and cos theta is 1 by 4. This will be what? 4, 14, root 15 by 7. Yeah, look at the options. The options you'll figure it out. They'll give you alpha is tan inverse or tan alpha, tan beta. All clear with this? Let's see one more. Last one for the day. People are exhausted today. Why? Why are you guys so exhausted already? Let's say mod A bar is 2, mod B bar is 3. And let's say angle between them is 60 degrees. Find mod 2A bar minus B bar. I don't want A plus B. I want 2A minus B mod. Let's see how you approach that. Okay. Root 19. We have two different answers. 13 looks too big, na? Let's think about this logically. Yeah. Even if I add everything in the same direction, what is 2A ka maximum you can get? 4. What is B ka maximum? 3. So if you add 4 plus 3, you can get 7. You can't get more than 7. So 13, there is no way it has an answer. Somewhere went wrong. So how do we do this thing? I taught you for A plus B. How do I do for 2A minus B? So see, you can just modify the formula. 2A bar plus minus B bar. Let me write it like this. So A ka place mein we have 2A, B ka place mein we have minus B. So let's think of it like this. So now your formula becomes A ka place mein we have 2A, so 2A ka square. B ka place mein minus B ka square plus 2, 2A minus B cos theta. There, you can do this thing. You can just put that whole thing in, replace A with 2A and B with minus B, and you're done. Yeah, you can also say, see, if A is like this and B is like this and the angle is 60, then minus B will be 120. So cos 120 is minus. So that is taken care by this minus sign here. So this is fine. This is a decent approach. So what is 2A? 4 square. What is B ka square? 9. That will be 2, 4, minus 3, and cos 60. Maybe you forgot the minus sign, I guess. That would be 9 plus 4 root 13. That would be minus 12. No, wait, what did I do? This is 16, right? Yeah, 25. 25 minus 12, that's root 13. Right, Myth. Forgot the root. Why you want to convert into I and J? How do you even know how the vectors are, Dhruv? What if A bar is like this and B bar is like this in X, Y, Z plane? Why should it be an I and J? Why can't there be K cap also? No? All clear with this? That's your, parallel of vectors. So it's more of a cosine rule. It's primarily, it's useful if you know the sides and you want to get an angle, or if you know the two sides and want to get the third angle, so, the third side. So yeah, but again, we will rarely use this. I don't remember using it much, once or twice, but yeah. The last thing, Lamis theorem. This also will not use it. But again, you will see some book or some notes and you'll see Lamis theorem and you'll think like, oh, what is this? We missed out. So we will just see what is it. There's nothing there. You will notice we have done this before already in a different way. If three vectors acting on a body are in equilibrium. Now, why we don't use this? Because this thing talks only about three vectors. What if there are 10 vectors? We have a better method, right? Resolution of vectors. So if there are more than three vectors, this thing fails. Then this thing says, so let's say we have a force F1, we have a force F2, and we have a force F3. So the angle opposite to F1, let's call it alpha. Angle opposite to F2 is called beta. Angle opposite to F3 is called gamma. Then this theorem says the side F1, the opposite of the sine angle alpha. F2, the opposite of the angle sine beta. F3, the opposite of sine angle is sine gamma. Did you guys see this somewhere? This is called a sine rule. So your parallelogram law is like cosine rule. Your Lamis theorem is like your sine rule. So there is nothing big deal about this. So just remember, there is something called Lamis theorem. So if you hear this somewhere, don't get scared. It is nothing. It is sine rule. We will not use anywhere this in physics. We have better methods. Like you can use this, but yeah, I won't use it anywhere. So this is A by sine A. And B by sine B is equal to C by sine C. What we did before is more superior. This thing, right? If you see, the problem is they are in a plane and everything. If you see the kind of questions we did, remember this problem? The three things are there. This is actually four vectors, isn't it? If you look at this picture, we have T1, T1, right? T1, T1, T2, mg. Gone. Your Lamis theorem you can't use here, right? If you look at this question, how the hell will you use Lamis theorem on two balls here? Can be done, but yeah, quite complex. So we have a much better method, taking a vector, resolving I cap and J cap and doing it. Clear with this so far? So that's about the Lamis theorem and the parallelogram of vectors. So that is the thing. Next class, the major thing, we have something called scalar dot product and vector cross product. These are important. They come a lot, right? Going ahead. So yeah, mostly we should be done. I think another 2 classes, mostly we should wrap up by next Monday. And maybe next Monday we'll start off with the introduction of calculus also, differentiation and integration. And on Wednesday, right, I'll give you access to the platform, the testing side, which I said, right? I will even upload a sample paper so that you can write and see how it feels and everything. And from next week onwards, we'll be starting off with our tests. So I'll send you the testing schedule also soon. Okay, with that, we'll wrap up for the day. So we have done almost like 22 questions. So please make sure to go through the notes. I'll also send you a sheet today for practice. You can give it a try, right? So yeah, any specific books, meaning, like I said, one, you must be getting your classes ka material. I also will be sending you material. We'll be dispatching it to your house. You can contact Vimy ma'am for the material. So my material, right, it has 6 levels. So it has something called theory bits. It's like your level 0, easy questions. Level 1, level 2, level 3, level 4, level 5, level 6. Not for all, meaning for vectors, it won't be there. Vectors is not a really tough chapter. So level 1 to 4 will take care of up to mains level, and little level 3 and 4 will take care of advanced, and 5, 6 will go high, advanced and higher. Right. So that is there. And still you want some books, I think you can go with H.C. Verma, standard book, and maybe you can go for DC Pandey. See, there are so many books you can, but if you ask me strictly, I would say just take 2 materials and just that's it, stick to them. Don't do more than 2 materials. But do them thoroughly. Maybe in the beginning, right, out of enthusiasm, you'll want to do everything, but after 2 months, you'll realize it's not working out that way. There'll be a hell lot of work to do. So better stick to 2 materials maximum, do them thoroughly. So yeah, stick to your classes ka material, okay, one, because see, your class ka teacher is going to ask, where is the homework done? And class ka material is not bad. Everyone has copied from everywhere. So all materials are good. You can do that. You can do my material, or you don't like that, you can do DC Pandey, or you can do HC Verma. You can choose any 2 materials. That should be fine. Right? So yeah, that is that. Cengage is good. Cengage is not a bad book, but yeah, per chapter you have around 300, 400 questions. You won't be able to complete it. That's the only problem I have.